Hey everyone, welcome to the last video for centroids, and this one we just want to take a look at one more example, looking at the centroid of a composite shape that's made up of functions and poles, things like that. So with this one, I went ahead and rewrote. You should have already seen a video kind of outlining where these formulas come from, which is the first video for the 2D laminas, so I won't reiterate that. And then we went through another video with the sine and the line example, so I won't go through that one again. But the formulas that we came up with, I just kind of rewrote right here for our reference. So, so those are right here. So you can see those again. Alright, so what we'll be doing is basically just running through how you do it with sort of this composite of functions, but then also, maybe holes or pieces added on, things like that. So the first thing I'm going to do is try to find the center of mass of this shape as if it did not have a hole in it. So just the parabola here with the square root function on the bottom. So I gave you kind of a hint in the title. This is a parabola, it is a square root. Otherwise, this would be pretty hard to identify down here. So go ahead and come up with some equations for that. So the parabola we can see as a vertex right there at 2, 4. So it shifted over 2 and up 4. It's flipped around negative. So we could say our f of x is going to be negative, and then the shift right 2, make this x minus 2 squared, and the shift up 4 will add 4 to that. And if you want to simplify this, you can. It does a little bit. It's not strictly necessary, but you could say this is negative times, and then square this out, so you get x squared 2 negative 2x's. You multiply that out, so that's actually, let's just put negative 4x right there, and then negative 2 times negative 2 would be a plus 4, and then plus 4 on the outside, and then the negative gets distributed, so we get a negative x squared, and then plus a 4x, and then a minus 4 and then a plus 4, and those will cancel out. So you actually just end up with this 4x minus x squared, or negative x squared plus 4x. That a lot of times, if you're going to be doing some of the calculations by hand, can definitely simplify things. If you're not, just using a calculator or computer, leaving it as you originally had it is fine. The g of x, we're going to do that one. So again, my top function is what I'm going to be calling f. My bottom function is g. So this is a square root. It's been turned upside down, so we get a negative in front for sure. And starts at 0, so it doesn't look like there's been any shifts or anything, but it has been scaled because the square root of 4 normally 2. So instead of being down here at negative 2, it's been halved. It's only right there at 1. So we're going to say this is negative 1/2 square root of x. Alright. So those are my two functions, and that's the main part of kind of getting this guy, and then I just have to run through all the integrals. So again, you could try to go through these by hand. We're not going to have time to do it in this video, so we're going to go over and use Desmos, but I'll go ahead and leave space here. So let's go ahead and record what my my mx and my m are going to be. So we'll leave some space for those. We'll go ahead and compute those over in Desmos. Alright, so I went ahead and typed some of these guys in. So there's my parabola. So I got 4x minus x squared. And again, you can restrict it just 0 to 4. That's not absolutely necessary, but if you like to see just the part of the shape you're looking at, you can do that. The negative 1/2 square root of x, also just right down there. You don't have to worry about trying to put in that extra line for our computation, so it's just that f and g that you need. the mx that we have, so this is going to be that integral 0 to 4, or sorry, my of x times f minus g, and this one's going to give me about 27.73 repeating. If you want to do the fraction, you can change it right there, but we'll just put the decimals. 0 to 4 of 1/2 of f minus g squared. So the f squared minus g squared. Again, you don't want to put the square on the outside. That will be a different number. But I got 16.06 repeating on that one. And then again, integral 0 to 4 of f minus g. This is just going to be my mass or my area. So 13.3 repeating. So we'll go ahead and put all those in. When I divide those out, I should get this 2.08 and this 1.205. So those will be my my over the mass or area, and then the mx over that mass area. So we'll go ahead and put all those numbers into the worksheet. Alright, so we're back at the note page, and went ahead and wrote those my, mx, mass down. The divisions with no, again this is with no hole, give me a centroid at x is 2.08 and y is 1.205. So you can put those in if you want. So 2.08 is about right here, 1.205, again maybe up here a little bit, so somewhere around there would be my center of mass if there were no hole in this shape. But there is a hole, so then what do we do with that? So we can use the ideas that we had from the composite shapes, which is if I have a center of mass and an area, I can combine those with other center of masses and areas to get kind of this composite of all of them put together. So what we're going to do is I'm going to go and switch colors real quick. So we're going to take this with my hole centered at 2, 2, and I'll go ahead and just rewrite this one in. So we know this centers at 2, 2. We know the mass of this circle, or the area that I'm going to use, is going to be pi r squared, and looks like a radius of 1, so pi times 1 squared will just be pi. Alright, so that's what I get for this guy. So when you're going through those, remember what you want to do is just take that moment, calculate the mx by taking the mass times the distance for the x if you're doing my, or for the y if you're doing mx, the mass times distance for each of those points and shapes. So we'll go ahead and write those out. So let's say my new my is going to be this value that I had before. So again, the mass or the area is that 13.33. So let's go ahead and put that down times this 2.08. So that's for the overall object. And then we're subtracting out this hole. So I need to actually do a minus here because we got a negative mass of pi, the whole negative area. And then times the x coordinate there, which is just 2. Alright, and I'll compute that out here in a second. Same thing for that mx. So this is going to be same thing, the mass of the first one. And usually when I calculate these out, I put in like a whole bunch of 3's, or I change it to a fraction. So be careful not to round too early on these guys, otherwise you'll be off. So 1.205 for that y coordinate, and then minus pi is the area times the distance up, which is 2. So x and y happen to match on this one for the circle. And then the total mass of this object with the hole is 13.3 repeating. And then again, we're taking out this area of pi for the hole, so minus pi. All right, so we'll go ahead and calculate those out, write those down. All right, so we got some numbers in here now. So this my comes out to about 21.45. Some extras. mx is about 9.783. Rest of those numbers, and then the mass 10.19174. So I divide the my. I got some numbers in here now. So this is going to be the 21.45 and stuff for the my, 9.78 and stuff for the mx, 10.19174 for the m. And if you divide those my over m, you get the x bar, so that's about 2.105. The y bar, 9.78 over that 10.19, so about 0.9599. You round it and about 2.105 and 0.960 to 3 decimal places. So that's going to be 2.1, so right around in here, and just a little bit more to the right. Right, it's not big difference from what we had before for the x, but the y is now below 1, about 0.96. So like right down in here. So this area right here would be about where we have our center of mass for that new shape. Alright, so that's it. You can see it's not much further to the right than this 2.08, but it is down below that -1, so that now that center of mass is right here. So you should be able to balance that on your stand. It's going to be pretty close to the edge right there. The center of mass may end up in the hole sometimes. You can imagine if this hole was a little bit lower, that would raise the center of mass a little bit, but it would also, put more weight out here. So that center of mass would be in this whole region somewhere in there. So it doesn't have to lie in the shaded region. It could be in the hole at some point, but it's just a matter of going through those calculations. And again, the moment above this point would be the same as the moment below this point. Even though it doesn't look like it, the distance that this is away from the point is really contributing to the center of mass being where it is. So that is getting a high moment with that mass at a further distance way out here. So here's some pictures of the sign and the line one that we did in the last video, just so you can take a look at those. Where those should be, and then this one that we did right here, you can again kind of draw that. It's going to be just below that hole right on the edge, and it should balance out. If it doesn't, maybe some cuts got off or something, you can always put a piece of Scotch tape across the hole and kind of balance it on there. It doesn't change the mass really that much for that, but you should be able to balance it without the tape. But if you need to, you try to just take a piece of tape across there. Alright, so that is it. I will give you one hint on this so here's some homework you can try, but before we go, one hint on this number 4. Just remember, with this one, you can kind of split it into 2 triangles here and a rectangle. These you would use your formulas to find the center of mass on each of those, and then rectangles easy to find, and then use those composite ideas just like we did on this last one. So hopefully that's it, and if there's any questions on these, you can always post them in the forums.